Concrete batch, plant operator study guide, part 2A, calculations and examples. Note, use Appendix C to solve the following example problems. A, calculating aggregate moisture from the cookout method. Information you will need to be able to collect. 1. W wet equals the weight of the wet aggregate and weighing pan in pounds. 2. W dry equals the weight of the oven dried aggregate and weighing pan in pounds. P. TW, the tare weight of the weighing pan. Determine the moisture content as a percent of the aggregate dry weight. 100 times the wet weight minus the dry weight divided by the dry weight minus the tare weight is equal to the moisture content in percents. Example 1. A sample of coarse aggregate is taken, weighed, that's your wet weight, dried, then reweighed, that's your dry weight. The weights measured are given below. What is the moisture content of the stockpile represented by the sample? The wet weight is 3.64 pounds. The dry weight is 3.45 pounds. The tare weight is 0.54 pounds. Calculate the total moisture content of the sample. Moisture content in percent is equal to 100 times 3.64 minus 3.45 divided by 3.45 minus 0.54. That is equal to 100 times 0.19 divided by 2.91, which is equal to 6.53%. Example 2. Your wet weight is 1,509.6 grams. Your dry weight is 1,476.4 grams. Your tare weight is 295.3 grams. Calculate the total moisture content of the sample. Moisture content is equal in percents is equal to 100 times 1,509.6 minus 1,476.4 divided by 1,476.4 minus 295.3, which is equal to 100 times 33.2 divided by 1,181.1, which is equal to 2.81%. B. Calculating free moisture in aggregate. Information you will need to be able to collect. 1. The moisture content. See examples 1 and 2. 2. Aggregate absorption. Total moisture content in percent minus the absorption in percent is equal to your free moisture in percent. Example 3. The total moisture content is determined to be 6.53% for a stockpile of coarse aggregate. This same aggregate has an absorption of 2.5%. What is the free moisture? Free moisture is equal to 6.53 minus 2.50, which is equal to 4.03%. Example 4. The total moisture content is determined to be 2.81% for a stockpile of fine aggregate. The same aggregate has an absorption of 1.4%. What is the free moisture? free moisture is equal to 2.81 minus 1.40, which is equal to 1.41%. C. Determine the adjustment to batch water quantity and aggregate quantity due to aggregate moisture. Information you will need to be able to collect. 1. Free moisture. See examples 3 and 4. 2. Weight of SSD aggregate used per yard cubed from the design mix. A. This calculation takes moisture content as a percentage of aggregate weight and turns it into a measurable quantity in pounds or gallons, to be used in the adjustment of both batch water and aggregate quantities. Convert the free moisture percent to a numeric value by dividing by 100%. For example, in example 4, the free moisture was determined to be 1.41%. The value used in calculating adjustments is 1.41 divided by 100, which is equal to 0.0141. Adjustment equals the aggregate weight times the converted free moisture. When the moisture content is greater than the absorption, the usual case, the aggregate will give up water to the mix. The aggregate quantity must be increased by the adjustment, and the water quantity must be reduced by the adjustment. B. The water adjustment can be left in terms of pounds or can easily be converted to gallons. 1 gallon of water weighs 8.33 pounds. So water adjustment in gallons is equal to the water adjustment in pounds divided by 8.33. Example 5. The example design mix calls for 1,620 pounds of coarse aggregate and 267 pounds, 32.0 gallons, of water per yard cubed. The aggregate has an absorption of 2.50%, and the total moisture content is determined to be 6.53%. Calculate the adjustments to batch quantities per cubic yard. Figure the water adjustment in pounds and gallons. 1. The free moisture is equal to 6.53. Example 5. The example design mix calls for 1,620 pounds of coarse aggregate and 267 pounds, 32.0 gallons of water per cubic yard. The aggregate has an absorption of 2.50%, and the total moisture content is determined to be 6.53%. Calculate the adjustments to batch quantities per cubic yard. Figure the water adjustment in pounds and gallons. 1. Free moisture is equal to 6.53 minus 2.50, which is equal to 4.03%. 2. Free water is equal to free moisture divided by 100 plus 1, which is equal to 1.0403. 3. Adjusted aggregate quantity, 1,620 times 1.0403 is equal to 1,685.286 pounds. 4. Determine the adjustment in pounds equals 1,685.286 minus 1,620, which is equal to 65.286 free moisture. 5. Adjusted water quantity in pounds is equal to 267 minus 65.286, which is equal to 201.714, which rounded off is equal to 202 pounds. 6. Determine water adjustment in gallons. 65.286 divided by 8.33 is equal to 7.84. 7. Adjusted water quantity in gallons. 32.0 minus 7.84 is equal to 24.16, which is equal to 24.2 gallons. Example 6. The example design mix calls for 1,366 pounds of fine aggregate and 267 pounds, 32.0 gallons of water per cubic yard. The aggregate has an absorption of 1.40% and the total moisture content is determined to be 2.81%. Calculate the adjustments to batch quantities per cubic yard. Figure the water adjustment in pounds and gallons. 1 free moisture is equal to 2.81 minus 1.40 is equal to 1.41%. 2. 1. Free moisture is equal to 2.81 minus 1.40, which is equal to 1.41%. 2. Free water is equal to free moisture divided by 100 plus 1, which is equal to 1.0141. Adjusted aggregate quantity 1,366 times 1.0141 is equal to 1,385.2606 pounds. Determine the adjustment in pounds. 1,385.2606 minus 1,366 is equal to 19.2606 free moisture. Adjusted water quantity in pounds is equal to 267 minus 19.2606, which is equal to 247.7394. We round that off to 248 pounds. Determine the water adjustment in gallons is 19.2606 divided by 8.33, which is equal to 2.31 gallons. Adjusted water quantity in gallons is equal to 32.0. Example 7. The following data applies to the design mix. Calculate the adjusted aggregate and water quantities. Moisture absorption quantity in divided by cubic yards. Coarse aggregate 1,620. Fine aggregate 1,366. Water 267 pounds, 32.0 gallons. Coarse aggregate free moisture is equal to 3.5% is equal to 3.5 divided by 100 plus 1 is equal to 1.035. Adjustment due to extra water in the coarse aggregate is equal to 1,620 times 1.035 is equal to 1,676.7000, which is equal to 1,676.7000 minus 1,620, which is equal to 56.7000 pounds free moisture. Fine aggregate free moisture is equal to 2.9%, which is equal to 2.9 divided by 100 plus 1 is equal to 1.029. Adjustment due to extra water in the fine aggregate is equal to 1,366 times 1.029 is equal to 1,405.6140 is equal to 1,405.6140 minus 1,366 is equal to 39.6140 pounds free moisture. Adjustment to the batch water is equal to 56.7000 plus 39.6140 is equal to 96.3140 pounds. Adjusted aggregate and water quantities are coarse aggregate 1,620 plus 56.7000 is equal to 1,676.70 is equal to 1,677 pounds. Fine aggregate 1,366 plus 39.6140 is equal to 1,405.61 is equal to 1,406 pounds. Water is 267 minus 96.31, which is equal to 170.686, which is equal to 171 pounds, which is equal to 171 divided by 8.33, which is equal to 20.5 gallons. D. Determine water cementitious material ratio and or batch quantities based on a given water cementitious material ratio. 1. The water cementitious material ratio is simply the total weight of all water in a batch divided by the total weight of all cementitious material, cement, fly ash, slag, etc. in the batch. Water cementitious material ratio, W divided by Cm, is equal to the weight of all the water in the batch divided by the weight of all the cementitious material in the batch. Example 8. The example design mix contains 545. Example 9. A 5 cubic yard batch is called for that requires 685 pounds per cubic yard cementitious and a maximum water cementitious materials ratio of 0.39. It is to be batched to allow 15 gallons of job site allowable water addition. How much water per cubic yard should be used in the initial batching? Figure total water required from WC and cement requirements. 0.39 is equal to the weight of water divided by 685 is equal to the weight of water is equal to 0.39 times 685 is equal to 267.15 is equal to 267 pounds. Convert to gallons. 267.15 divided by 8.33 is equal to 32.07 is equal to 32.1 gallons per cubic yard. Since 15 gallons are to be held back from the entire load for allowable job site addition, the holdback per cubic yard is 15 divided by 5 is equal to 3.0 gallons per cubic yard. The load should be batched with 32.1 minus 3.0 is equal to 29.1 gallon per cubic yard to allow 15 gallon addition at the job site and a maximum water cementitious materials ratio of 0.39. Example 10. A 1 yard batch was delivered to the job site which called for 545 pounds of per cubic yard cement, 140 pounds per cubic yard, 21.00 gallons of batch water, 1,620 pounds per cubic yard coarse aggregate with a free moisture of 1%, 1,366 pounds per cubic yard fine aggregate with a free moisture of 6%, 0.000 gallons added at the job site. Determine water cementitious materials ratio of the 1 cubic yard delivery to the job site. Coarse aggregate 1,620 divided by 1.0 plus 1 divided by 100 is equal to 1,603.800. 1,620 minus 1,604.000 is equal to 16.000 pounds of free moisture. Fine aggregate 1,366 divided by 1.00 plus 6 divided by 100 is equal to 1,288.679, which is equal to 1,366 minus 288.679 is equal to 77.321 pounds free moisture. Convert the gallons of water to pounds. 2100 times 8.33 is equal to 174.930 pounds of batch water. Total water in the batch, 16.00 plus 77.321 plus 174.930 plus 0.000 is equal to 268.251 pounds. Total water, 268.251 pounds. Total cementitious, 685 pounds, equals 268.251 divided by 685 is equal to 0.392. WCM ratio is equal to 0.39. E, specific gravity, unit weight, absolute volume, yield. 1. When talking about specific gravity, everything is compared to water. Water is considered to have a specific gravity of 1 and has a unit weight of 62.4 pounds per cubic foot. If something has a specific gravity greater than 1, it is more dense, weighs more per cubic foot than water. Specific gravities have no units of measure, cubic foot, pound, etc. 2. To determine the unit weight of a material with a known specific gravity, multiply the material's specific gravity by 62.4 pounds per cubic foot. Unit weight of material, pound per cubic foot, is equal to material specific gravity times 62.4. Example 11. Determine the unit weight of cement. Specific gravity is equal to 3.15. 3.15 times 62.4 is equal to 196.56 pounds of cubic foot. 3. To determine the absolute volume of a certain amount of material, divide its weight by its unit weight. Absolute volume is equal to weight of material divided by specific gravity of material times 62.4. Example 12. Determine the absolute volume of 1,366 pounds of aggregate with a specific gravity of 2.61. 1,366 divided by 2.61 times 62.4 is equal to 1,366 divided by 162.864, which is equal to 8.39 cubic feet. 4. To determine the yields of the example design mix, total the absolute volumes of all the ingredients, including air and, in general, disaggregating admixtures. To determine the unit weight of a mix, divide the yield by the total weight of all the ingredients. Example 13. Determine the yield and unit weight of the example design mix. The ingredients: cement, fly ash, coarse aggregate, fine aggregate, air, and water. It gives you the unit weight and gives you the calculation in the absolute volumes. Yield is equal to 2.773 plus 0.923 plus 9.834 plus 8.387 plus 0.945 plus 4.279 is equal to 27.141 cubic foot. The unit weight is equal to 545 plus 140 plus 1,620 plus 1,366 plus 267. You divide that by 27.141, which is equal to 3,938 divided by 27.14, which is equal to 145.1 pounds per cubic foot. 5. When the specific gravity of one of the batch materials changes by more than 0.08, adjustments need to be made to the mix design quantities to prevent over or under yielding. To calculate the necessary adjustment, determine the volume of the original specific gravity using the new specific gravity. Determine the weight required to fill the volume that was just calculated. You will find that if the specific gravity goes up more dense, it will take more weight of the material to fill a given volume, and if the specific gravity goes down less dense, it will take less weight of the material to fill a given volume. The original mixed quantity in pounds divided by the original specific gravity times 62.4 is equal to the volume from the original specific gravity in cubic feet. The volume from the original specific gravity in cubic feet times the new specific gravity times 62.4 is equal to the new mixed quantity in pounds. Example 14. The example design mix calls for 1,620 pounds of coarse aggregate with a specific gravity of 2.64. It is determined that the specific gravity of that aggregate is now 2.60. Determine the new design mix quantity for this coarse aggregate. 1,620 divided by 2.64 times 62.4 is equal to 1,620 divided by 164.736, which is equal to 9.834 cubic feet, is equal to 9.834 times 2.60 times 62.4, which is equal to 9.834 times 162.240, which is equal to 1,595.47, which is equal to 1,595 pounds.